Okay, welcome everyone. Thank you for sticking out to the last session, but we have two presentations we're going to pack into this last hour, both on the subject of face recognition. Firstly, we have Jason Matura from VID000, who's going to be talking about face recognition and how VID000 are leveraging GPU. And you're not Jason.
Okay, so cool. Thank you for the introduction. This is Denise. He's joining us from Kiev. He's one of our engineers. So, like we mentioned, we're merging two of the panels together. Ours is on general approaches towards facial recognition and pictures and images, and then Anton from NVIDIA is going to be presenting on face detect, which is one of the many filters that we use. So what we're going to do is I'm going to do about 10 minutes, and then we're going to, once we get to the pipeline piece and we hit face detect, Anton's going to come up and give his presentation, and then we're going to merge the Q&As at the end. It's actually kind of good because we've been working a lot with NVIDIA and even with Anton on optimizing our own face detect for GPUs using some of their knowledge. So the title to the session is important. It's Practical Approaches to CPU, GPU, Facial Recognition Pipelines. So why I say practical approaches is that there's lots of known techniques out there kind of that work on the server environment, that work they take forever to process. And I think what's important with what we're going to show you now is that we are in the business of selling stuff. So VID000 is a startup. We're a company. We're selling products. We have clients. So the stuff that we're going to show you at a very high level is how you actually do this on deployed platforms. And you're going to see very quickly why the GPU is an extremely critical piece of actually pushing this stuff to consumer platforms. So first off, what we're not going to present. So it's how we take faces and translate into distance functions. This is our core algorithm. That distance function is how we tell if people are alike or not. That's kind of the secret sauce. And what feature space we use too is proprietary. So RIP, just to give you a sense of kind of what RIP covers as a company. 1 is in facial recognition, 2 in clustering, and 1 patent in multi-classifier fusion. So the 2 in clustering shows you actually how important clustering is to getting this to a practical deployment. And that's actually where I'm going to focus most of my presentation is in the techniques used for clustering. So roll again. Okay, so briefly, we're about 25 people. Most of them are in Kiev. There's 2 of us out here in the US. And then, like I said, we have several clients in our production. So here, just as I know this is really, really general, but here's part of the problem with facial recognition. So it's Tina Fey, Sarah Palin, sometimes we can't even tell which one is different, and Denise. So if everything works correctly, we should, most of the time, be able to tell the difference between Sarah Palin and Tina Fey. And definitely we should be able to tell the difference between one of those women and this guy. Okay. So what I'm going to show you now is, so we process some video through our engine. Now this is about 2 or 3 minutes for each person. And what you see is going on here is what we call clusterization. And this is a really, really cool way to visualize it. And also starts giving away some of the clues as to why the GPU is so good at this. So what you see here is this is one person, this is another person, and this is another person. And the important thing is that there's actually no connections between those 3 clusters. If the 3 clusters are all together, that means we don't know who they are. And the more distance we have, the better. And what's interesting about this cluster right here is that you can see it's uniting very disparate images and saying that it's the same person. So when you get down to the level of the user, clustering is extremely, extremely important because if you can't build dense clusters, that means that you're asking the user to assign more and more tags, which is a really terrible user experience. And the more dense this cluster is, the more tags and reference images you associate to the person for the recognition, so the better. Let's actually zoom. Let's go in. So what you can see here, and this is Sarah Palin. So you can see that all these different aspects of her are united, and we can tell that they're the same person. And you can see that this image right here is very, very different from the one that's at the top. And this is at a really small scale. So the one that's at the top of this group is going to be really, really different from the one that's at the bottom of this group. And you can see that she looks quite different than the stuff that we were seeing up there. So go to the edge between this cluster and that cluster. So this is the hard one right here, because this is Tina Fey. And we made the difference, and there's no link between Tina Fey with glasses and then Sarah Palin with glasses. Now, it's actually really, really difficult because they do look a lot alike, and you can see in what aspects they look alike when these clusters start to get together. And then the other one's pretty easy, so Denise, go up to the top and just show the difference. Go to the edge. So, I mean, obviously, unfortunately, I mean, Denise, even with glasses, doesn't look anything like Sarah Palin. And he looks even less like Tina Fey. So, but this is a really, really important concept as we move forward. And this is really where we spend most of our processing time, is in building these clusters. Let's go to the next slide. Oh. Go to the next, please. Okay, up one. So right here is a generic face recognition in video pipeline. It's actually pretty similar for photos. I know we're supposed to cover both, but we actually, as a company, focus on video. So what you have is you have a video clip. You have to in some way decompress that video clip and get it into an analysis engine. And then an analysis engine, what you're doing is you're first face detecting, and then you're clusterizing. Then you're taking those clusters and you're trying to suggest them against a person's database. And of course, if there's no match in the person's DB, then you present it to the UI for a tag. All this is built into a metadata, and you make it available via an API. So this is kind of the framework with which you look at it. And you want to take, when you're looking at using GPUs, you want to take each piece of this and figure out which piece is best to go on the GPU. Obviously, the decompress, everybody knows GPUs do fantastic work there. I think what Anton's going to show is that it actually does really, really good work on the face detect, which is actually a pretty heavy filter to run, and you can run it several times with different characteristics, and the GPU is perfect for doing that. And then the clusterization is actually running our core comparison algorithm, and that's making those clusters as dense as possible. We actually, this is just a kind of, we haven't yet done the port ourselves on the suggestion side. That's because our stuff is running low level enough on the CPU. So I guess this is a good place that I'll let Anton kind of take over. And I'll put this in the context of, so all this stuff that we're doing right here are a bunch of different filters that we're running. And you can immediately see why the GPU is going to lend a lot of horsepower to this, because we can parallelize in multi-dimensions. So all this stuff can be parallelized here. And then, of course, you can parallelize it across both frames, hours, minutes, whatever you want to in the video, just because of how video is. So I'm going to hand it off to Anton.
Yep.
You want to go into the face detect.